Hello there everyone. In this video, we're going to find missing angles using trig. So in previous videos, we've set up trig ratios using sine, cosine, and tangent. And then we've also solved for missing sides using sine, cosine, and tangent. When we plug an angle into our trig function and we set up the ratio of the sides. Okay, but what if we don't know the angle? Then we're going to use what's called inverse trig. And these are functions that are used to find angles. So this is sine inverse, cosine inverse, and tangent inverse. All right, you see they have the little exponent of -1. And then if you go over to your calculator, if you'll see the blue part, on mine at least, above sine, cosine, and tangent, those are your inverse trig functions. Okay, so in example 1, A and B are the acute angles in two right triangles. Find their measures to the nearest tenth. Okay, so you'll see we've got sine of A equals 7/10. So like if I drew a right triangle here, and this was angle A, the opposite over the hypotenuse would be 7/10. But I don't know what this angle is right here. So this angle A that I don't know is currently trapped inside of sine. So what I'm going to do is I'm going to apply sine inverse to both sides. And what's going to happen there is that the sine inverse and the sine are going to cancel each other out. So A will equal sine inverse of 7/10. So then if I go over to my calculator, I got second sine, which is going to pull up this sine inverse, 7 divided by 10. I'll get angle A. The measure of angle A is about 44.4 degrees. So the measure of angle A equals 44.4. Okay, let's roll over to example B. In example B, I've got this right triangle. Let's say angle B is up here. The cosine of B is 9/13, which means its adjacent side is 9, the hypotenuse is 13. So what I'm going to do is I'm going to apply cosine inverse to both sides. That's going to cancel out the cosines. On the left-hand side, just leave me with B, equals cosine inverse of 9/13. So then over in my calculator, I hit second cosine. Oops, didn't show up. Second cosine, there we go. 9 divided by 13, or 9/13. And I'll get that the measure of angle B equals 46.2 degrees, if I'm rounding to the nearest tenth. Okay, so that's if we've got it all set up for us. What about in example 2, where I give you a diagram? Okay, so I'm giving you a diagram. So I'm trying to find the angle in question. So this one's the question mark. I'm going to replace this with our theta, just so we get used to dealing with that letter, talking about angles, theta for angles. So what is 36 to that theta? That's my opposite. What's 53 to that theta? That's my hypotenuse. So opposite and hypotenuse is going to be sine. So if I've got sine of theta equals 36/53. Well, notice my variable, this theta, is trapped inside of sine. Okay, so if it's trapped inside of sine, what I'm going to do is do sine inverse of both sides. Because I need to undo sine. I need to get rid of the sine to get the theta by itself. So that's going to cancel out the sine. So I'll get theta equals sine inverse of 36/53. So we get second sine, 36 divided by 53. And I'll get theta equals 42.8 degrees. So that's the theta there. In B, we've got, instead of question mark, I'll say theta. What is the 10 to my theta? That's the opposite. What's the 41 to my theta? That's the adjacent. So we got opposite over adjacent, so that should ring a bell and say we're dealing with tangent here. So tangent of theta equals opposite 10 over adjacent 41. So toa, opposite over adjacent. So theta is trapped inside tangent. So I'm going to apply tangent inverse to both sides. Cancels out the tangent. So I'll get theta equals tangent inverse of 10 over 41. So then second tangent, 10 divided by 41. And I'll get theta is about 13.7 degrees. All right, so that's how we use inverse trig to find missing angles. The angle is trapped inside of a sine, cosine, or tangent function. So in order to undo sine, cosine, or tangent, we use this inverse trig. Okay? And just to show you, just because I don't know if my calculator will do it, in case you want to type it in as a fraction, if I do second tan and I get tan inverse, if you've got this graphing calculator and if you hit alpha y equals, the first button is going to turn it into a fraction for you. So if you didn't know how to use, form a fraction on your calculator, I just wanted to show you, if you hit alpha y equals, you can create a fraction. All right? So anyway, that's just a tangent, no pun intended. So if we go on, a couple you try nows. Now that we know how to solve for missing sides and missing angles, now that we know how to do that, we can solve for a right triangle. Now, what solving for a right triangle means is find all three sides, find all three angles. So, a couple things to remember as you try these problems before I see you in class, please. Before I see you in class, make sure you try these. You've got trig to solve for missing sides and angles. You've got Pythagorean theorem. If you've got two sides, you can do a squared plus b squared equals c squared. Need two sides. And you've got the triangle sum theorem. The triangle sum theorem, remember, says angle 1, the measure of angle 1, plus the measure of angle 2, plus the measure of angle 3 equals 180. So if you have two angles, you can quickly and easily solve for that third angle. So if I go up to these problems in this second triangle, I know one of my angles is 90. I know one of my angles is now 13.7, so I could easily find this third angle. I don't need to use trig again. Okay, so make sure if you're solving a right triangle or finding a missing side or angle, you are using the easiest method to do that. Okay, so you got trig, Pythagorean theorem, triangle sum theorem, something like that, okay? So you got two you try now problems where I'm asking you to solve for a right triangle, solve the whole right triangle. If you have any questions, please let me know. Other than that, get these problems done before I see you in class. Have a good one.